Ben, before you head out of town, I was wondering if you could take a look at our roof assembly and tell us your thoughts about it.
I'd love to. What you guys have going on here is a classic over roof insulation situation. This is what, 5 inches?
Yeah.
Yeah.
Yep.
And this is kind of an assembly that I haven't seen before, but I like how you guys came up with this and why you're doing this. You have what, your cantilevers here
Yeah.
to give you the overhangs and the projections you're looking for with your soffits. Typically what we do is we'd install the insulation here, and then we'd come back over and we put a piece of lumber on top of it and screw down through, which is tricky because with long screws and thick insulation, it becomes difficult to accurately hit our members underneath and get really, positive attachment. So you guys have come up with a clever system. Gonna see this?
Yeah,
Travis?
absolutely.
And just kind of talk through this. So you guys put down your comfort board here, right? And then you're gonna just take and put a standard piece of dimensional lumber right off the shelf and toenail it.
That's it.
This is pretty brilliant.
We're trying to do this for speed.
Yeah.
And that makes sense because one of the complaints with, some high performance assemblies is that they're labor intensive, which is true, or that you need, specialized crew with high skill levels to be able to pull them off. And this solves for that problem.
It will be completed by our framers, and we think, we'll probably have it in tomorrow. Another nice thing about this product is once it's in, you can walk on it, and there is almost no give. It is dense.
And that's what enables you guys, if you use this product, to do your, what do you use, like a 1x4 on top?
Yeah, you can
for
either
your
use a
nailing
1x
base?
or a 2x depending on what the requirements are.
So you drive that structural screw through, and it can only suck down so far. I mean, I'm 210. That point load doesn't even make a dent.
Yeah.
So you don't really have to worry about that structural screw making your roof wavy when you use this high density product. And of course, being on a roof, the fact that it's vapor open, hydrophobic, those are all things that are a benefit in this situation. The thing that we really wanted to emphasize with this assembly is we came to the table with, we really want to make this house as great as it can be. And that means continuous insulation. The jacket going on when you go outside instead of stuffing cotton between your ribs. Seabrook's brilliant with that. What we are trying to accomplish here with that over roof detail is that jacket, that continuous exterior insulation, but because we're the ones that are pushing for that and the client didn't come and say, what I really want is as much insulation as you can put on the top of the roof as possible, we're kind of driving that ship. So we've got to balance that cost.
Yeah.
And that's what you're talking about, the complexity of structural screws, making sure you land on the member. That's a little bit slower for our framing crew. They don't like to drive screws, they want to fire nails.
Yeah.
So what we've given up in a thermal bridge where our trusses, which are lined out here with this red line beneath, that's where our truss is located. By being perpendicular to that with our framing system, we're talking about basically a 1.5 inch by 1.5 inch thermal bridge.
Yeah, with a nail in it.
Which is negligible.
We're gonna take so much on camera for only carrying one board at a time. What kind of self-respecting framer carries one board at a time?
Yesterday, our framers wrapped up the perimeter. Today, Travis and we're gonna go ahead and insulate the infill.
So we're using a Comfort Board 110 on this application because it's a low slope roof. There is also Comfort Board 80, and then of course you could just use a Comfort Bat depending on the pitch of your roof and the application. The 110 is a higher density, 11 pounds per cubic foot. The 80, 8 pounds per cubic foot. That's giving you your resistance. If you step up on it, your feet don't press into it. So you could do a strapping on top of this and screw it down with a structural screw, and that's why the 110 was chosen. We're gonna go ahead and just lay these bundles right up against the rims that the framers laid out yesterday for our cantilevers, and then we'll take our next board, which is essentially a roof joist in this application, toenailed into the trusses below, lay in the next row, and we'll do some cuts on the ends as needed, but pretty fast install. We'll show you.
Yep.
For the sake of speed, which is kind of what we're all about. It's about efficiency over here. We're not going to start with a cut. We're going to lay the board in tight to the corner, and then after we frame in the next row, we'll make those cuts after. We got to cut it anyway. That's the one spot where I'm willing to live with a cut. If we come in here, this is as simple as kicking it tight, as long as I don't make that corner too tight. I'm going to stay right at that 45, but that allows us to be tight against our rim. Again, this is our thermal boundary. The wall of the house, the exterior wall, is right below this plane. So we're continuous thermal barrier across the roof, into the attic, R38 on the underside, R38 down to the wall. Wall's 23 on the inside, 8 on the outside. So at this point, we're ready to break bundles and just start slinging it in. So one of the things we talked about with Ben yesterday is the hydrophobic property of this material. It literally is rock, it's basalt, and it's spun like cotton candy in a blast furnace to allow this fibrous structure, but you can see the water beads right up on the top. So I'm not worried about a little bit of water on this product as I would be with a cellulose or even a fiberglass.
Yeah, I think if you lifted it right up, it would run right off.
That's the beauty of the product. That's why we chose it. In order to make this quick, which again is the idea of our work here, we want to be productive, we want to be efficient, that's how we make our money. We're going to go ahead and try to mass produce some of these 45-degree cuts here. And I know it's a 45, well, even though Wolfgang framed it, I know it's a 45 because I can read from my pivot point across my protractor, 45 degrees. So I know this angle will be 45. I can do easy carpenter math to make this work. I know I've got a 2-foot wide board, so I should end up with a 2-foot right triangle. I'm not going to figure the hypotenuse, I don't care. What I am going to do is cut 2 by 2 along the 45, lay that board in, and we should, because this is a 48-inch material, end up with 4 of those triangles per board by making 2 diagonal cuts and 1 straight cut. So 45, 90, 45, 4 triangles all the way up the side. Guess now I have to do it, huh? Talk enough about it, pretty soon they want you to show it. 2, 2, here as well. And what I'll do is I'll cut this shallow so that I don't destroy the board underneath it, and then I'll stand it up to finish the cut. You've seen us do that before on our Instagram, @CatalystBuilt. When we do underslab, you'll find that we routinely scribe our line to start the cut on the comfort board and then stand it up to finish the cut out. Look at that. Ta-da!
One thing I'd like to point out about this method is by starting our full sheet at the corner, it's going to automatically stagger our joints.
Oh, that's brilliant.
Yeah.
I hadn't even thought of that. You're quite right. You can see this is why we didn't nail them first. We could have nailed all these out just the way these are nailed down, and we would have had to force every single one of these in. But if we had a bowed 2x6, all of a sudden now we're fighting it. We got to cut the boards. Even though it's fast to cut, it's longer than throwing them down. So by doing it this way, this makes it fast for your framer. Your insulator could work together even. Your framer could be up here just nailing boards. Your insulator could be throwing comfort board, and that would all work fine. You'll notice, here's my red line. That's my truss below. This board, I could have cut it to split right on there, but it's not worth the effort. I don't need it structurally. This is just holding up the sheathing on top of it. There's no real other force acting on it except uplift. The engineer says the toenails are adequate to prevent that. So what we'll do with our next board is we'll just toenail into the top, toenail through the side, and that's adequate for the structural sheathing application that we're using here. Up here, rather than roll out hose and have one more thing to trip over, we've got Joe's Milwaukee cordless framing gun. So this is gonna start going really fast. We're slowing down so that we can demonstrate the techniques, but the whole idea of this assembly is blow and go. As long as you're doing a good job, keeping your joints tight, making good cuts, there's no reason this needs to be a slow process. This is a moneymaker. So as we got to the end of this run, we were about to cut a 22, which is our length from the edge of this section of comfort board to our outside edge of roof. But if you remember from the earlier shots where we were down below, we have some substantial overhangs built into this, in addition to our over roof that has that narrow fascia detail. So our thermal boundary is actually not here. It's 43 inches further back than even this. So just like we talked about how we're not insulating out over those bays because they're outside of the thermal boundary, same condition here. Our outside wall of the house occurs here, 43 inches in from this point. So any insulation we leave long on this is just for efficiency, so that we don't have to cut another board. Because when we insulate the underside of the roof deck with our ComfortBatt R38, we will actually turn that material down to be in plane with the exterior wall. So just like we want continuity of water barrier all around the house, air barrier all around the house, continuity of thermal barrier is very important. And that is what we're doing here. So this saw works great. The folks at Rockwell engineered this side to cut the ComfortBatt product, which is a little less dense. The more frequent teeth go straighter through this product, but my hand's getting tired faster because my hand is in a awkward position as opposed to like this. So that's this versus that. For the 5-inch material, this is worth having. We cut 2-inch for the whole sides of the house all day with this, perfect. And we've actually done all the underslab with 3-inch, same knife. We just got this to try on the 5-inch. I think it's worth having for arm fatigue, or hand fatigue. So you may have noticed we have two different products on our over roof, two different insulation products. What we have here is the 5-inch ComfortBoard 110 that we talked about earlier. High density, you can walk on it, you could screw furring strips through the top. It's rated for the compressive strength to have direct contact. And in fact, when we lay out our sheathing on this, then since it's the 24-inch thick product, we'll probably do sheathing splices and it won't be an issue because it's structurally rated for that compression. The other product that we're using up here is a ComfortBatt. The ComfortBatt R23 is not available in the full 24. It's available in a 22.5 or a 14.5 because it's designed to tuck into wall cavities. This is in the full 24x48. This is the 22.5. And this is not nearly as dense. You can see I can compress that down. So this product with that smaller width works great in our over roof structure at the cantilever. So as we talked about laying these boards in and doing it quickly, toenailing through the trusses, we can't do that on the edge. because the structural engineer says in order to have this cantilever, we really need the shear nailing. It's not just compressive. We're actually dealing with some shear forces that we want nailing on the traditional pattern for our OSB sheathing. So this is on a 22.5 cavity or a 24-inch center, whereas this space is a 25.5-inch center. And that allows for the 24-inch comfort board to fit in that cavity. So again, on the cantilevered sections where we need that shear nailing, we have to have that layout. In the middle, we don't need that, so we don't have it. We've got the higher compressive strength material. This is easier to work with. We don't have to saw this with the effort that it takes to cut through this dense of a product. That density does come at a labor price. So in order to make these jobs affordable to our client, we got to reduce that labor time. That's why we're not doing the structural screws through furring strips. It's slow, we risk damage to the truss, drives up the cost. So we're trying to do this best possible assembly for the best value. That's what we're trying to deliver to our client, and that's why the two different products. As with any assembly, the most complicated part is the transition. Nobody has leaks in the middle of the roof. You always have them at a roof boot. Nobody has air leakage in the middle of the wall. It's always at the window. So we have concerns anytime we make a transition from one material to another, one plane to another, changing angle, changing shape. That's the hardest part. One of the things that we enjoy about working with the Rockwell product is the density of the material, not just from the handling like we've already talked about, but also because there's a condition known as wind washing that happens especially with a vented roof, where if you were using a fibrous insulation, the air that comes into the attic to vent the roof deck moves through the insulation and effectively reduces the material's ability to protect from thermal losses. So while this is not a vented roof assembly, I can still demonstrate that we don't have a concern when using this product if it were a vented roof assembly, because the density of this product prevents those convective loops that you have to worry about in a wind washing condition, where the air moves through the insulation and reduces its temperature to meet the outdoor air. The dense product allows us to go ahead and block that, because you can blow through this, especially the Comfort Bat, which is a little less dense. I can blow through it and the wind could blow through it, but it's a much reduced rate. The density of the Comfort Board 80, the Comfort Board 110, we don't really have any concern at our roof eaves where we would have to, put in a solid block to prevent that wind washing of wood. We don't have to put that block in. There's no wind washing going through that material. It's incredibly dense, and that's why you could see us walking around on it without even leaving a boot impression. No wind washing, high density, low risk.
So we finished up our exterior insulation. We've got our R8 installed on the wall and our R20 installed on the roof. We're getting ready to cover that up with our decking. And after we get through our mechanicals, we're gonna start our walls. We're gonna do a Comfort Bat R23 on the exterior walls, and we're gonna go with a 38 up against the underneath side of the decking on the roof.
Yeah, and before we do that, obviously, we're gonna get in here and pull some wire. Joe's gonna run some pipe. We're gonna get our mini split line sets pulled and get all of our mechanicals buttoned up first. And when you guys come back, we'll go ahead and talk about the way we detail those penetrations, working through the exterior insulation to make sure we keep our water and air barriers intact. So you'll notice behind us, we have stud cavities framed 16 inches on center. And this is a 2x6 exterior wall framing package, where ordinarily we would prefer a 24-inch on center to limit our thermal bridging. The structural engineer called for these to be 16 on center, and that's what we've got, so we can go ahead and accommodate that with an available product. Obviously, Rockwell will ship you their Comfort Bat in either 2x6, 24 on center, or 16 on center. And then, of course, you can get that for a 2x4 wall as well. As Joe already pointed out, we'll be using the R38 between the trusses above. So you have all the different product depths at the different widths that you need, regardless of your structural wall framing.
With the combination of our exterior insulation and what we're gonna put in the walls, we're gonna be about an R30 in our walls, and our ceiling is gonna be about an R58. We're gonna do 38 against the roof deck, and we have 20 on the top. And we're excited about it. It's gonna be great.
Possibly the highest insulated home in the area. We're really excited and proud about this because we think it's going to make a difference.
Yeah, and one thing our homeowner is really excited about is how quiet the roof is going to be. We're going with a metal roof, and he's concerned about rain. You know, obviously we live in a hail area, so that could be an issue also, and he's looking forward to not hearing it. We've completed our exterior insulation on both the walls and the roof, and our thermal envelope is complete now. So what happens next, Travis?
Next up, we're going to go ahead and put up a rain screen over this Rockwool material. So a rain screen is great about extending the life of your home, the durability of having your paint job last 15 years, 20 years longer than it would if it was just siding against sheathing, because it can't dry on the back. So a rain screen helps manage that water, one of the other control layers like we were talking about.
Yeah.
We're going to put up a dimple mat on this for the stucco to be applied to, because this is a stucco finish. And you'll see more of that in the future.